Have you ever stood next to a solar panel on a bright sunny day and thought about what is actually happening inside it? There are no moving parts, no fuel being burned, no turbines spinning, just a flat, silent sheet of dark glass sitting in the sun, and somehow, electricity is coming out the other side. It looks like magic. And the deeper truth is that the science behind it is so strange, so counterintuitive, that when Albert Einstein first explained the principle that makes solar panels possible, almost nobody believed him. In fact, it was not his theory of relativity that won him the Nobel Prize. It was the discovery that sits at the heart of every solar panel on Earth. Here is what makes this even more remarkable. The sun has been sending the same energy to Earth for 4.5 billion years. We have only just figured out how to catch it. And the way we do it involves a phenomenon so bizarre that it rewrote the rules of physics entirely. Welcome to History Behind Simple Things. Today we are uncovering the extraordinary science behind how a flat piece of glass turns sunlight into electricity. To understand how solar panels work, we first need to understand what sunlight actually is. Sunlight is not just warmth and brightness. It is a stream of tiny packets of energy called photons. These photons travel 150 million kilometers from the surface of the sun to Earth in about 8 minutes. They carry no mass. They carry no electric charge. They are pure energy moving at the speed of light. When those photons hit most surfaces, they are simply absorbed as heat. That is why dark pavement gets hot in summer and why you feel warmth on your skin standing in sunshine. The photons arrive, transfer their energy as heat, and that is the end of the story. But in a solar panel, something completely different happens. The photons do not just transfer heat. They knock electrons loose. This is the phenomenon Einstein explained in 1905, and it is called the photoelectric effect. When photons of sufficient energy strike certain materials, they transfer their energy directly to electrons inside the material, knocking those electrons free from their atoms. The electrons, now free and carrying energy, can be directed to flow in a specific direction. A flow of electrons in a specific direction is the definition of electric current. That is electricity. But not every material responds this way. The material that solar panels use to capture this effect is silicon, the same element that makes up most of the sand on Earth and the same element at the heart of every computer chip ever made. Silicon is a semiconductor, meaning it sits between a conductor like copper and an insulator like glass in terms of how it handles electricity. This middle ground property is exactly what makes it useful for solar panels. Here is where the engineering becomes genuinely brilliant. A solar cell is made of 2 layers of silicon that have been treated differently. The top layer has extra electrons added to it. Engineers call this N-type silicon, N for negative. The bottom layer has electrons removed, leaving behind positively charged gaps. This is called P-type silicon. When these 2 layers are pressed together, they create a junction between them. And at that junction, something remarkable happens automatically. The extra electrons from the N-type layer drift toward the gaps in the P-type layer, creating a built-in electric field pointing from the bottom layer upward toward the top. Now when sunlight hits the top layer and photons knock electrons loose, that built-in electric field does not let those freed electrons wander randomly. It pushes them in one specific direction, upward, toward metal contacts on the surface of the cell. From those contacts, the electrons flow out through a wire, through whatever device needs powering, and return to the bottom of the cell to complete the circuit. That continuous flow of electrons through a wire is exactly how your phone charges, your lights turn on, and your appliances run. One solar cell produces only a small amount of electricity, roughly half a volt. So cells are connected together into modules. Modules are connected together into panels. Panels are connected together into arrays. A rooftop solar installation might have 20 to 30 panels working together. A utility-scale solar farm might have hundreds of thousands. All of them doing the same silent, motionless thing, catching photons and turning them into moving electrons. So the next time you see a solar panel sitting quietly on a rooftop, soaking up the afternoon sun, remember what is actually happening inside that dark glass. Billions of photons arriving from 150 million kilometers away, each one knocking loose a tiny electron, each electron being pushed by an invisible electric field through a wire and into your home. No fuel, no fire, no moving parts. Just physics, working exactly as Einstein said it would. If you enjoyed discovering the hidden physics behind this simple thing, hit that like button. Share this with your close friends. And subscribe to History Behind Simple Things and leave a comment telling us where you're watching from. And I'll see you in the next one.